Let us see question number 1 of exercise 7.1. Here it is given ABCD is a quadrilateral and AC is equal to AD and AB is bisecting angle A. What is the meaning? Angle CAB is equal to DAB, and you have to prove that triangle ABC is congruent to triangle ABD. Okay, and they have asked further, what can you say about BC and BD? So let us see the proof of this. Okay. So in triangle ABC and triangle ABD, what you have to do? You pick out the corresponding parts, congruent parts, and prove it. So in triangle ABC, what you can say? AB is equal to AB. Okay, side AB is equal to side AB. What you can say? It is a common side. Okay, so common side. Then so here I will write for your understanding, it is a side. Okay, then angle BAC is equal to BAD. This is given to us. Why? AB is bisecting angle A. So this is one pair of corresponding angle, you can say angles. Okay, and AC is equal to AD. This is also given to us. AC is equal to AD. This is given. Okay, so this is a side, a corresponding pair of side. So side angle side. So therefore you can write, therefore triangle ABC, okay, is congruent to triangle ABD by which rule? So here you can write side angle side by side angle side rule, or you can write the word by congruence rule, side angle side congruence rule. Now they are asking, what can you say about BC and BD? Now you proved these two triangles congruent, therefore the remaining parts are congruent. So it implies that, okay, about BC, and so BC is also equal to BD. You can also write congruent also. Reason? By CPCT, corresponding parts of congruent triangles. Okay, hope you have understood this question number 1. Let us see question number 2. Here also ABCD is a quadrilateral in which AD is equal to BC. See the identical markings. And angle DAB, this angle, is equal to CBA. Then you have to prove these three parts. Triangle ABD is congruent to BAC. Then BD is equal to AC, and angle ABD is equal to angle BAC. Let us see the proof of this. Okay. So in triangle ABD and triangle BAC, okay, you prove these two triangles are congruent. So how will you prove? You can see ABD, so AD is equal to BC, okay, or you can say DA is equal to CB. You maintain symmetry, okay, nothing else. So you can write AD is equal to BC. Okay, I will write, this is one pair of corresponding side, so I am writing here. It is not necessary to write, okay, but for your understanding I am writing, it is given. Then angle DAB is equal to CBA. Angle DAB is equal to angle CBA. So this is one pair of corresponding angle, so angle I am writing here, and this is also given to us. Okay, you can refer the question. Okay, check the question, it is given. And then what else? AB is equal to BA. AB is a side of triangle ABD and BA is also side of triangle BAC. So AB is equal to BA, it is a common. So I will write here AB is equal to BA. So this is also side. So I will write here given common. So it is a common side. Okay, so we proved. So therefore triangle ABD is congruent to triangle BAC by which rule? Side angle side. So SAS congruence rule. Okay, now once the triangles are congruent, the remaining parts are automatically congruent. So it implies that BD is a part of triangle ABD and AC is a part of triangles ABC. So BD is equal to BD is equal to AC, reason by CPCT. Okay, and what else you want to prove? Angle ABD. ABD is angle, so corresponding angle is BAC. So this angle. So and also it implies that angle ABD is equal to angle BAC. So this is also by CPCT, corresponding parts of congruent triangle. Hope you have understood question number 2. Both these questions you have understood. Let us see question number 3 of exercise 7.1. It is given that AD and BC, they are perpendicular to the same segment AB and AD is equal to BC. Okay, you have to show that CD is bisecting AB. What is the another meaning? CD is bisecting AB means CD AB के दो बराबर पार्ट्स कर रहे हैं AB के. So that is AO is equal to BO. ये हमको प्रूव करना है. See the proof. Okay. Now it is given that it is given that BC is and AD is perpendicular to AB. What is the meaning? BC is perpendicular to AB and AD is perpendicular to AB means this angle is 90, this angle is 90. What is the relation between BC and AD? They are parallel lines. Okay, so I will write here. Okay, AD is perpendicular to AB and BC is perpendicular to AB. It implies that BC is parallel to AD. Okay, now in triangle OAD and triangle OBC. Okay, now you have proved that BC is parallel to AD, and if you consider CD as a transversal, then this angle is congruent to this angle. So we can write angle ADO is equal to angle BCO, alternate interior angles. Okay, alternate interior angles. Okay, what about AD is equal to BC? AD is equal to BC. This is given to us. Okay, yes, and angle D, yeah, or you can say OAD. Angle OAD is equal to angle OBC. Reason each 90 degrees. Okay, therefore triangle OAD is congruent to triangle OBC by which rule? Angle side angle. So you can write by angle side angle rule. Okay, now once you proved these two triangles are congruent, it implies that remaining parts are congruent. So we will take AO is equal to BO. So AO is equal to BO. Reason by CPCT, corresponding parts of congruent triangles. Hope you have understood this question number 3. Let us see question number 4. Here L is parallel to M and there is one more pair, P is parallel to Q. Okay, and you have to prove triangle ABC is congruent to CDA. Okay, so from the data I have written given and to prove, let us see the proof of this. Okay, so in triangle ABC and triangle CDA, we will find out the corresponding parts. Okay, so if we consider P and Q are parallel lines, and if we consider AC as a transversal, then this angle is congruent to this angle. So first we will take angle BAC. Angle BAC is equal to angle DCA. Okay, DCA. So I am writing here in brackets, this is one pair of angle. Reason A for angle. Reason alternate interior angles. Okay, alternate interior angles. Okay, then AC is congruent to CA, so common side. AC is equal to CA, so this is side. I will write S. So here I will write reason common. Okay, so it is a common side. And if we consider L is parallel to M, and if we consider AC as a transversal, then angle ACB, this angle, is congruent to CAD, this angle. So we will write angle ACB is equal to angle CAD. So one more pair of angle we got. So ASA. Okay, this is the way we have to write. It is not necessary to compulsory to write this, but if you write, it gives a good impression on examiner, and you can find out, he or she can find out easily. Okay, by which test you have used. So here reason same, alternate interior angles. Okay, alternate interior angles. So therefore we can say triangle ABC is congruent to triangle CDA by ASA, congruence rule, or you can simply write rule also, congruence rule. Hope you have understood this question number 4. Let us see now question number 6 of exercise 7.1. Okay, if you observe this figure, then you will understand AC is equal to AE given to you, and AB is equal to AD. Now when you say AB is equal to AD, then you are focusing on triangle ABD, and you are getting triangle ABD as an isosceles triangle. Same is the case with triangle ACE. When you say AC is equal to AE, then you are getting a triangle ACE as an isosceles triangle. Again, they have also given that angle BAD, this angle, okay, this angle is equal to angle EAC, this angle. Okay, then you have to show that BC is equal to DE. Now when you say BC, then you are focusing on, you should focus on triangle ABC, and once you say ABC, it is not an isosceles triangle or equilateral triangle also. If you say ABC, okay, then side AB is not equal to AC. You can find out from identical marking. Same case, and you have to show that if you focus on triangle ADE, you are getting this side is not equal to this side. Okay, so what is your target? You want to prove that BC is equal to DE. So when you say BC means what? It is a side of triangle ABC, and DE means side of triangle ADE. So you should be successful in proving triangle ABC is congruent to triangle ADE. Okay, things are given, but when you say triangle ABC, then angle BAD plus angle DAC, this angle if you will add DAC, then you will get angle BAC. Similarly, if you add DAC in angle CAE, okay, or EAC, then you are going to get angle EAD, and they are equal. Let us so we will prove these two triangles are congruent by side angle side rule. Let us see. Before let us prove this. Okay, now first of all I will write, see carefully, angle BAD is equal to angle EAC. This is given to us, correct? So I am adding DAC in both the to both the sides. Okay, BAD plus angle DAC is equal to DAC plus angle EAC. So what it implies, BAD plus DAC. So I am getting here angle BAC. Okay, and DAC plus EAC, I am getting angle EAD. So we will call this result number 1 and we will use this. Now you can focus on triangle ABC and ADE. Okay, let us see. Now in triangle ABC and triangle ADE, okay, so AB is equal to AD. What is AB? AB is a part of triangle ABC and AD is a part of triangle ADE. So AB is equal to AD. This is given to you. So here we will write here A for angle. Okay. Sorry, not angle. It is a side. So I will write here side S. Okay. Here I will write reason given. Okay. Then angle BAC. Angle BAC is equal to angle EAD, or you can write DAE. Okay, I will write EAD. So this is angle from where? From result number 1. Okay, so I will write here from 1 we are getting this, and AC is equal to AE. What is AC? AC is the side of triangle ABC. AC and AE, you can see from the name, AE is the side of triangle AD, so AE. Okay, here I will write side, S for side. So see, side, angle, side, this is also given to us. So what we can write? So this implies that triangle ABC is congruent to triangle ADE by side angle side congruence rule. Side angle side congruence rule. Okay, so this implies that BC, what is BC? BC is a part of triangle A, side of triangle ABC. It implies BC is equal to DE. Okay, you can write here by CPCT, corresponding parts of congruent triangles. Hope you have understood this question. Let us see question number 7 of exercise 7.1. So here AB is a line segment, P is a midpoint. So I will write AP is equal to BP. Identical markings I will show. Then angle BAD, this angle, and angle ABE, you can see identical markings. So these two angles are congruent. One more pair of identical angles is congruent. So as you can say, angle EPA, double markings are there, see, and DPB. Your target is, you want to prove triangle DAP is congruent to EBP, and then you want to prove that AD is equal to D. Let us see the proof of this. Okay, here also if you observe, angle EPA, and if you add an angle EPA EPD, then you are going to get angle APD or DPA. Same case, if you add EPD in EPB, okay, then you are going to get EPD plus DPB is a angle EPB. Let us see. Okay, we will start with angle EPA. Okay, this they have given angle EPA is equal to angle DPB. Okay, this is given to you. Okay, then if you will add So therefore angle EPA plus angle EPD, adding EPD on both the sides, plus angle DPB. So what you are going to get? So EPA plus EPD, you are going to get APD, or you can say DPA. So you can say angle DPA is equal to angle, same way, EPD plus DPB is nothing but EPB, is equal to angle EPB. You can call this result number 1 and you can use this. Now you focus on triangle DAP. Okay, now, okay, in triangle DAP and triangle EPB, okay, what you can say? DAP. So we can say angle BAD, that is angle PAD. Okay, angle PAD is equal to angle PBE. Okay, PBE. This is one pair of angle, corresponding angle. I will write here given. Okay, then what else? AP is equal to PB. AP is equal to PB. So this is side. So I will write S for side, and here also we will write given. Okay, then angle DAP, DPA. Okay, angle DPA is equal to angle EPB. This is another pair of corresponding angles. Here we will write reason from 1. Okay, so angle side angle. So therefore triangle DAP is congruent to triangle EBP by angle side angle congruence rule. Okay, once these triangles are congruent, corresponding parts are congruent. So we will write AD is equal to BP. What is AD? AD is a side of triangle DAP. You can see DAP. So AD is a side. Okay, and what is B? B is a side of triangle EPB. So BE. Okay, so AD is equal to BE. Okay, by CPCT. See students, how I am writing here A is a pair of corresponding angles as well, or sides. It is not necessary to write, but you can understand very easily. Okay, and you can understand what you are writing. Oh, that's for that purpose I am writing. Hope you have understood question number 7. Let us see question number 8 of exercise 7.1. Here in triangle ABC, angle C is a right angle, therefore AB is a hypotenuse. M is the midpoint of hypotenuse AB. C is joined to M and it is produced up to D. Okay, such that DM is equal to CM. So I will show by identical marking. Second thing, M is the midpoint of AB. It is given, therefore identical markings. Okay, here we will show 90 degree. Okay, then you have to show triangle AMC is congruent to triangle BMD. Angle DBC is a right angle. Triangle DBC and ACB are congruent, and CM is half of AB. All these things, 4 different things we have to prove. Let us see the proof. Okay, so in triangle AMC and triangle BMD, prove these 2 triangles are congruent. So we will take AM is equal to BM. Here we can write given, this is given, and this is a pair of corresponding sides. Okay, so I will write here side and not not angle. So it is a pair of corresponding side. Then angle AMC is equal to angle BMW. Okay, BMD, sorry, BMD. Okay, reason vertically opposite angle. So this is one pair of corresponding angles. Okay, then CM is equal to DM. CM is equal to DM. This is also given. Okay, so this is one pair of corresponding side. So therefore triangle AMC is congruent to triangle BMD by SAS, side angle side rule. So we proved this. Okay, this is our first part which they have asked. Okay, we proved these two triangles are congruent. So what therefore what you are getting, therefore we are getting AC is equal to BD. Okay, therefore we are getting AC is equal to BD. Okay, reason by CPCT. Also, angle MAC is equal to MBW. Also, angle MAC is also equal to MBD, not W, MBD. Okay, same reason by CPCT. Now, MAC, that is what? BAC, that is angle BAC is equal to MBD, meaning ABD, that is angle ABD. Now what you can say, BAC means this angle and ABD means this angle. Both these angles are equal and they are forming a pair of alternate interior angles. So this tells that, so this implies that AC is parallel to BD. Okay, this tells that AC is parallel to BD by converse of alternate interior angles test. By converse of alternate interior angles test, you can say. Okay, now you proved AC is parallel to BD. So therefore, so what we are getting? If DB is parallel to AC and if you consider BC as a transversal, then angle DBC plus angle ACB is, their total is 180. Reason, they are forming a pair of interior angles. Okay. Interior angles, therefore TBC, now ACB is given, angle C is 90. Okay, therefore angle DBC is 90 degrees, is a right angle. So we proved this. This is our second part. Now we want to prove triangle DBC. Now, okay, now in triangle DBC and triangle ACB, you find out the corresponding parts. So we will first write okay, DB is equal to DB is equal to ACB. Here see AC is equal to BD, so that is DB is equal to AC we can write. So DB is equal to AC. Okay, we can write proved above. Okay, proved above. So this is nothing but one pair of sides, corresponding side. Then angle DBC is equal to angle ACB, each 90 degrees. So this is one pair of corresponding angles, and BC is equal to CB, common side. BC is equal to CB, reason common side. Okay, so this is one more pair of corresponding sides. So therefore triangle DBC is congruent to triangle ACB. By which rule? By SAS rule. By side rule. So once you proved these triangles are congruent, so the remaining parts are congruent. So therefore we can write DC is equal to AB. Okay, this is by CPCT. Corresponding parts of congruent. You will ask why DC, we have taken DC is equal to AB, because our target is CM is half of AB. Now how is DC we can write? DC we can write as DM plus CM is equal to AB, and it is given that DM is equal to CM. So I will replace DM by CM. CM plus CM is equal to AB. So therefore 2 times CM is equal to AB. So therefore CM is equal to AB by 2, that is CM. So 2 means 1 upon 2. 2 is in the denominator, so half multiplied by AB. So we have proved these four different things. Hope you have understood this question number 8.